Next presentation by Marco Boschini, how to reach remote devices behind the net and to build a VPN concentrator with MikroTik.
Thank you, Lorenzo. Welcome to my presentation. I'm Marco Boschini. I'm from Italy. I am a MikroTik certified trainer, and I live in Desenzano near Garda Lake. Today we are going to discuss about the scenario of a remote device, how to reach remote device with the net problem. You can use router S as a VPN server. We're going to discuss about the basic routing concept, the most difficult stuff for my students to understand when create a VPN server. Router S as a VPN client when the router is the main router, and VPN client when the router is not the main router, but is the client inside the LAN. And how about if two or more customers have the same network subnet? And how about security? And in my opinion, the best VPN client to connect the customers. What is a remote device? This is the schema of the scenario. This is a device inside a LAN without a public IPv4 address. Some devices cannot implement security mechanisms that are required today, such as authentication, authorization, and encryption. Authentication is used by a server to determine, to know exactly who is accessing the information or the site. In authentication, the user or computer has to provide its identity to the server. Usually authentication is by username, password, certificate, and two-factor authentication. Authorization is a process by which a server determines if the client has a permission to use a resource and is combined with the authorization. Encryption involves the process of transforming data, so this is unreadable by anyone does not have the decryption key. For example, when you use HTTPS, you must use encryption to protect data. So, in the field of building automation, where I work for a lot of times, there is a lot of device installed today and installed in the past that does not support authentication, authorization, and encryption. There is some protocols developed many years ago that is very simple, efficient, and open without royalties, but these protocols have become a de facto standard being implemented and have a problem with security mechanism. One of these is Modbus, is developed by Modicon in the 1979. Today is property of Schneider Electric, is widely implemented. MikroTik implemented this protocol in the IoT packages for IoT devices, for example, the Knot, that you can use with a simple router with a USB attached USB converter. Modbus permit to exchange raw data within device in a common binary language. You can read values, you can write values to this device. Modbus RTU is available over a bus line, and Modbus TCP is available over a TCP/IP connection. KNX is another standard worldwide utilized, developed in the 19, and this is like the Ethernet protocol for networking, simple, robust, and future-proof, implemented by over 500 of manufacturers worldwide, and there is more than 500 of training centers around the world. The communication device is over bus cable. IP connection is also available from 2007, and IP secure connection is also available. KNX suggests use VPN connection to reach remote devices and not use destination NAT. And in the white paper, KNX proposed to use MikroTik as a solution with zero tier. I'm also an official KNX tutor instructor, and at some point of my life, I felt that it was necessary to connect the dots regarding these technologies and helping people to build solid competency, because these technicians sometimes doesn't have the knowledge about networking. And I build a training center where, with physical equipment to create a training course. This is the reason why I use love MikroTik. It permits to everyone to study networking and growth. It is affordable to utilize in every situation. We need practice to familiarize and better understand these topics. It's very flexible. It helped me to solve problems a lot of times. Almost all devices have all the functionality without paying extra money or subscription. How to reach these remote devices? To reach this device, there is multiple solutions. One is destination NAT with like port forwarding, the cloud, or a VPN solution. Destination NAT is a function of a firewall NAT. It permits to change two parameters in the IP packets, the destination IP address or the destination protocol port. But it's not secured because it exposes the device on the wide area network. Everyone can try to log in with brute force attack, and everyone can send a lot of packets to the device for the distributed denial of service, for example. You can limit access with firewall filter combined with address list, and also it requires a public IP. Also, dynamic IP is okay, but with the lack of IPv4 address today, it can be difficult having a public IP address. And also with mobile data, it's very difficult. The cloud is another way, but it requires manufacturer implementation. Data storage is on the cloud. It's available. If it is available, it's ready to use. You have to write cloud, but you have to read. It's on someone else's computer. You have no control over this technology. VPN is a secure direct connection. It can be created from a remote client, from the VPN client to the customer router, VPN server. VPN server must have a public IP to be reachable from remote VPN client. RouterOS implement different type of VPN server for this scenario. OpenVPN, WireGuard, L2TP with combined with IPsec, Secure Socket Tunneling Protocol, IPsec, and PPTP, but please don't use it anymore. If the customer does not have a public IP, the VPN server cannot be reachable from the customer. A relay server is required. Now we are going to create an OpenVPN server in 5 minutes. VPN server requires certificate and credential, user and password. OpenVPN permit to push route to the client. It is possible since 7.17 to create multiple OpenVPN server on the same device with different protocol, for example, TCP and UDP, and to connect this OpenVPN inside a specific VRF, for example. First off, we have to create the certificate authority. Is a 2 row of configuration. You have to create the OpenVPN certificate authority. You can set days of this certificate is valid, and you have to sign the OpenVPN certificate authority with a control host. In this example, I use localhost. And now we are going to create a server certificate, and we have to sign this certificate with the OpenVPN certificate authority. And we have to create the OpenVPN client certificate. You have to sign this certificate with the OpenVPN certificate authority. And now we can export this certificate, the OpenVPN certificate authority, without passphrase, but for the OpenVPN client, you have to export the certificate with the passphrase that we will use this passphrase in the next slide. Where we find this certificate? Under System Certificate, you can find the certificate, and under the File menu, you can find the certificate exported. The server configuration is quite simple. Please note that this configuration is from RouterOS version 7.0. 17 with not set the server, but add the server with OpenVPN server 1 as the name. You have to set the OpenVPN server certificate, the protocol, the default profile with encryption. Thank you, Ron. Thank you, Barry. And you can push routes to the client since RouterOS 7.14. In this case, I will push 192.168.1.0/24. Okay. And you can export the configuration directly from RouterOS. One of the most difficult configuration in the past was to create the file from scratch, and it doesn't work a lot of time for me. Okay. Now, MikroTik help the technicians with the functionality of export the configuration for the client. Interface OpenVPN server, export client configuration, server address, you have to insert your public IP address of the server, the certificate authority, file export, and the certificate of the client, and the certificate key of the client. We have a file in the menu file with the configuration OpenVPN for the client. You have to create the users in PPP, point-to-point protocol secrets, add a name, a password. You can set a specific service for using this credential. And in my case, I choose to use a specific IP for the remote device for the client to add some security features in the next slide. But you can use a pool of IP addresses. How to create the connection for the customer? The customer have to install the OpenVPN Connect in his phone or in his computer. Have to import the OpenVPN file in OpenVPN Connect app. You have to insert the username, the password, and the certificate secret key. Okay, you can save this value inside the app and select Connect. It works. Okay. Connection from Windows PC is almost the same, and connection from the Mac OS is almost the same. But how about Linux? I use Linux, and for the Linux, there is a client. You have to save the remote OpenVPN configuration file inside your machine, and via secure copy, you can copy the configuration from the router to the client via command line interface, of course via graphical user interface, but I'll most use the command line interface. And after, you can save the credential in the same directory, creating a new file, two new files, one for the user authentication and one for the secret of the certificate. And you have to edit the configuration, inserting the two files that contains the credential. And with the command sudo openvpn --config the configuration file, the connection is okay. RouterOS can be an OpenVPN client. You can import the OpenVPN file inside the router, and you can insert the username, the password, and the secret key, and the RouterOS become an OpenVPN client with the certificate or without the certificate. RouterOS to RouterOS, you can remove the use of the certificate for the client. But there is another problem if your router or VPN service is not reachable by public IP. There is some solution, zero tier, back to home, based on WireGuard protocol, and RouterOS as a VPN server concentrator. Zero tier is available only in ARM64 architecture, only from version 7 of router S, free up to 25 devices, can be hosted for free in your local environment without the limitation of 25 devices. Last year, Alessandro have a great presentation about zero tier. I suggest you to find this presentation if you want to deep dive into these arguments, and not under your complete control. iOS, Android, PC, Mac, Linux apps also is available. Back to Home is a new functionality of MikroTik. Is available only in ARM, ARM64, and Tiller architecture. Very easy to implement, only 2 clicks. Based on WireGuard, MikroTik maintain for free the release server. It's not under your complete control, but iOS, Android apps is available, very easy to use. And PC, Mac, Linux can use WireGuard client as a client. How to enable this functionality in EP Cloud? Set DNS enable functionality yes, and set back to home VPN enable. And now we have the back to home functionality running behind that. How to use this VPN connection? You can scan the QR code via back to home MikroTik application, or you can use the text configuration, cut and paste inside a file, and you can use a standard WireGuard client, import the configuration file, importing the configuration file, and the VPN works. Okay? But this technology is available only for some type of architecture, and starting from some type of version of router S. I have a lot of customers with router S version 6 or with SMIPS architecture or MIPS beginning architecture. With the router S as a VPN server, is available with all of the architecture. You can build a VPN server with a router S, and you can build this solution with a physical device. With any devices can be a router S server, and with virtual device like CHR. Do you know CHR? The option is available are on the same of every device without limitation. So we are going to discuss some basic routing concept before to introduce the solution. A router forwards packets by looking at the destination IP address at level 3. A router searches for the interface where to forward out the packets inside his routing table, selecting the best path. If a home automation device, in the previous slide, this device, want to send data to the TVCC device, send the packets with the IP destination of this device, and the router looks to the routing tables to find the best path to send out, to forward out the packets. When the TVCC device will respond back to the original sender, create an IP packet with the destination IP address, and the router search the destination inside his routing tables, and the communication works. These routes are connected because, from the point of view of the router, these routes are connected because the router has an interface with an address that belongs to that network. There is no distance. They are directly connected with the final network. This router instead is not directly connected. There is a distance more than 0. All the static route is minus with minimum with a distance of 1. You can set more specific route with a specific destination, or only specific route without the default route. During the forward process, routers do not change IP addresses inside the IP packets. The router only forward packets. They don't touch the fields inside IP packets. MikroTik has a VPN client as a main router This is the schematics. The first router that we have previously created as an OpenVPN server is router 1. Now we have to connect router 2, the main router of your network, okay? And the router 2 is connected via OpenVPN with the main router. And you are the customer, you are connected to the router 1 that have a public IP address that it can be reachable. The router is the main router of the network, and every device is reachable because the router is the default gateway of the remote network. To install the VPN client, it is required to change at the main router of the network. The installation can be difficult. Okay, this situation needs to change some stuff inside the network. OpenVPN client as router S as an OpenVPN client is quite simple. Interface OpenVPN, add name OpenVPN to router 1, connect to the public IP of the server, protocol UDP, server user router 2 is the credential, my strong secret. Route no pool, in this case, I don't need to receive the pushed route. The pushed route is only for the customer, not the remote router, and profile default encryption. So when the customer wants to send the IP packets to the remote device, the customer have the route pushed from the OpenVPN server and know the correct way to send the packets to the destination and send this packet inside the OpenVPN tunnel. Router 1 receives these packets and it knows how to reach the destination because I have a static route inserted in the routing table, but you can dynamically create this route with the PPP secret field route, okay? Dynamic in this case. And the route send the packets to the router 2. Router 1 send the packet to the router 2, looking for the destination. And the router 2 know the routes to reach the remote device because it's a dynamic, active, and connected routes and send out the packet to the destination. The device check the source IP address to respond back, and this address 10.99.99.2 is not inside his network, and he chooses to send the packets to the default gateway, and the default gateway is the OpenVPN client, and the OpenVPN client can send back the packets to the router 1, is the main router. The router 1 know the routes to send back the packets to the original sender. It works. Please notice that router 2 receive as /24 routes because in OpenVPN server you can set what is the subnet mask that you will send to the client. In another VPN type, such as Secure Socket Tunneling Protocol, it is not possible. It is a 32 subnet mask. And how about if the router is not the main router because it is not possible to change the topology of the network? Okay. In my case, at some point of my life, a gynecologist said to me, "Congratulations, you are going to become a dad of 2." And in that case, I realized that I cannot go to the remote customer every day, but someday I have to do the dad job. And I created this solution to reach remote device, only sending router to the customer with a DHCP client enabled on the interface, and I asked to my customer, please plug the router inside your network, and all the configuration is automatically created to reach remote device. This is the situation. In this case, the router is a host in In the network, like a printer or like a smartphone, the router is not the default gateway of the device, and OpenVPN can be installed easily with the HTTP client configuration. This is the new topology, the main router. We have no control over this router, a switch, the device, and our router. The original customer tried to send the packets to the router 1. He knows the routes to reach the destination. The main router knows the path to reach the destination. The router 2 knows the path to reach the device because have a dynamic, active, and connected routes, and send out the packet to the final device. But the final device, when try to respond back, send the response to the default gateway because the original IP is outside his network and the communication doesn't work. What can I do? Can I change the source IP address of the packets arrived from the VPN client of the router itself? Yes, of course. This is the packet flow simplified. Remove the stuff that doesn't need. This is the destination NAT, and this is the source NAT in post-routing. Here, it is possible to change the source IP address. And with a single rule of firewall NAT, you can add that in the chain of the source NAT for the source address of the VPN. You can masquerade the original sender IP with the IP setting on the output interface of Ethernet 1 in this case. Router 2 masquerade the original IP with the IP setting on the interface and forward out the packets to the device, final device. And the final device now respond to the router because he's in the same subnet. And router 2, with the connection tracking functionality, reverts the original IP and send back the IP packets to the router 1. And router 1 know the routes to send back the packets to the original sender. It works, but in my case, all the customers have the same subnet. I only send the router, but all the customers, almost the customer have 192.168.1.0/24. What can I do? I can, what can I do? You can use what I call the fake route, means not real, because the router forward packets by destination address, we can use not real destination, okay, only to forward packets. And in this case, you can use an alternative, not real destination, 10.200.1.0/24, for example. And the router 1 send via push functionality the routes to the remote customer, and the customer know the routes to reach this not real destination, but send the packets to the router 1. The router 1 know the routes to reach this not real destination, but send out the packets to router 2. And in router 2, can we modify the packets? Yes, of course. You can change the destination IP address with the real destination IP address in the destination NAT. In this case, we have to add another rule in the firewall NAT with destination NAT change, the source IP address from the VPN destinated to the fake route. You have to change with the netmap. The netmap, you change the network part of the address, and not only one IP. You can change these parts, in this case, 10.200.1 with 192.168.1.10. And this is what router 2 do. Remove the source, remove the destination, and change the 2 IP addresses inside the P packets, and send out the packets to the device. The device responds back to the router 2, and the router 2, with the connection tracking functionality, revert the change that he have made with the original IP, and send back the packets to the router 1, and the router 1 send back the packets to the PC 1. It works, okay? How about security? At the start of my presentation, I discussed about some security trouble in some device. With this solution, you can implement authentication, VPN tunnel required authentication, use a password, certificate, or two-factor authentication. And authorization, router S implement a stateful firewall. With the router S, you can use address list functionality, and you can bind specific client with specific single IP addresses, and a single user can reach a single device, not all the remote subnet, but specific IP address. And this is the reason why I choose to use a specific IP on the PPP secret configuration and not the pool, for example. You can build a list with source address and destination address, all it so that the client reach the destination and drop everything else. This is the packet flow with the EP firewall filter functionality. This is where you can do the filtering. And how about security? Encryption, VPN tunnel can encrypt the communication. In my presentation, my first goal is about simplify the configuration of VPN 7. I have not touched the encryption setting, but you can set strong encryption, okay? And this is in my opinion, the best VPN client to connect the customer. OpenVPN client is available in every platform, newer and older. It's considered secure in almost of the world. It uses strong encryption. The use of the certificate is possible, and it's very easy to configure in the server side. I hope with my presentation you can have an easy way to implement this. And you can send configuration file to the customer via email or WhatsApp or Telegram. And for the customer, it's very easy to import the file. Just tap the finger on the screen and open with OpenVPN Connect application. And one of the first problem, when I realized this solution, I started with L2TP IPsec VPN. But from Windows, for example, from Windows PC, you cannot insert a specific route. You can use the default route, and the customer navigate, surf the internet via your VPN. And if a customer try to print a file with his printer, it doesn't work because the traffic go out inside the VPN. With the OpenVPN, starting from 7 to 14, you can push route to the client from the server dynamically without write on the client side the routes, specific routes. And VPN connection cannot be the default gateway in that case. And client reach internet via his connection and reach only the device that you need via VPN. By the way, WireGuard is another great choice. Yesterday we have a very good presentation about WireGuard. It's secure and fast. By the way, it's available only from router version 7 and not version 6. In my case, it's important the version 6. It is not possible to push routes to the clients. You must manually edit the config on the client device, and they're required to resend the configuration to the customer. But you can easily implement the same concept with WireGuard. I did the same configuration with WireGuard, with OpenVPN, with SSTP, with other type of VPN tunnels. So in this presentation, I have touched a lot of points. I started from scratch to make very clear the way to reach this lab to work. Understanding routing process and the packet flow is very essential to understand this configuration. Here you can find the official packet flow from MikroTik documentation, and every single point you have to open this box with another diagram to understand the packet flow. To deeply understand this presentation, I suggest trying it out on some labs and analyzing packet with Wireshark, for example. When I find some some trouble to understand one topic, OSPF, BGP, DHP, OpenVPN, all the topics, I always open Wireshark and always watch inside the packets where is the information. It's very important to do if you want to become a very professional. Last year I presented a solution how to create these virtual labs with GNS3 is an option. There is another type of virtual network emulator like EVNG or like a VirtualBox or Proxmox. You can use a different type of solution. In my opinion, GNS3 is a good choice because it's open source, is available on all the architecture. If you don't know how to create labs or where you start, watch this presentation. You can scan the QR code. I presented from scratch how to create your own virtual network lab. I also created a virtual machine ready to use with a desktop environment. It's based on Antix Linux. Is a very light distribution based on Debian with a very light power RAM consumption, and all is ready. I used this machine to do the net install, for example, the Dude client, Winbox 3, Winbox 4. And Wireshark is, if you are interested, is available for free from my website. And you can create labs to understand what you are doing. And you can use Wireshark integrated. To capture the packets. This is the configuration that I have created for preparing this presentation. And in Wireshark, you can see the IP fields. So, as a trainer, I always encourage my students to don't quit if you find some trouble during the learning process. And 2 years ago, I want to become a trainer. I don't speak English. I started to study English. And when my students have some problem to understand, I always keep in mind you have to retry, you have to understand better these arguments, and you have to fixed dreams, but without dreams, without goals, are just dreams. And ultimately, they fuel disappointment. On the road to achieving your dreams, you must apply discipline, but more importantly, consistency. Because without commitment, you never start, but without consistency, you never finish. Thank you for your time.